Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2017 Maths Methods Exam 1, suggested solution. Like always, before I start guys, if you guys want private tutoring, you can always email me through this email. With my tutoring, you get a dedicated, Discord server where you can speak to many of the students that are in that course. And, you get thousands of past exam questions for specialist methods, physics and chemistry as, I tutor those subjects. If you guys, want that, you can always email me through this email. So, let's start through this video. Okay, question 1. If f of x is this, differentiate f with the respect of x. Okay, so we're going to use the equation rule. So our u here is x, our v here is x plus 2. So what do we know? We know that u dash is 1, v dash is 1. And we know that it's f dash of x is x plus 2, 1, minus x all over x plus 2 squared, which simplifies to 2 all over x plus 2 squared. So that's your final answer. So that's f dash of x. Done. Let g of x be this, evaluate g dash of 1. Okay, very easy. So g dash of x is, bring that 3 in the front, find the derivative of the inside function, which is just negative 3x squared, and rewrite the whole expression, but now minus 1 from the power, which is 2. Now we want g dash of 1, that'll be 3, negative 3, 2, 1 squared, negative 9, 1 squared, which is therefore negative 9. So g dash of 1 is actually equal to negative 9. Question 2. Y equals this. Find dy dx. So we're going to use the product rule. So our u here is x. Our v here is log e 3x. Our u dash is 1. Our v dash is 1 over x. So our dy dx is x times 1 over x plus log e 3x, which is 1 plus log e 3x. Okay. Hence, it means hence. When you see the word hence, it means using the question before to help you do this question. So using the question they've done before to help you with this question. Hence, calculate this integral. Express your answer in the form of this, where a is a positive integer. So, okay. Well, we don't know how to calculate the integral of log, but you should know that they're telling us to use this expression over here. So we're using integration by recognition. So what do we know? Well, we know that the derivative, so the ddx of x log e3x, so the derivative of this, which we've already calculated, is 1 plus log e3x. So doesn't this expression equal to this expression? So if I wanted to integrate this over here, like both sides. So if I integrate both sides, so ddx x log e 3x dx equals the integral of 1 plus log e 3x dx. Because this is what we want to find, this expression over here. What is the integral of that? So what should we know? Well, we know that these cancel out because integrating the derivative just cancel out. So it will just become x log e 3x equals the integral from 1 plus log e 3x dx. So here's our expression that we're going to use. So we know that the integral of this expression equals this expression. That's very useful. Now, knowing that, I'm going to say the integral from 1 to 2 log e 3x plus 1 dx is equal to x log e 3x from 2 to 1. So that simplified to 2 log e 6 minus log e 3. Okay, so what do we know? Well, we know that this, we can put this power on top of this, so we can say log e 36 minus log e 3. And we know by log laws that these two expressions, what's 36 divided by 3? Log e divided by 3, that's 12. This is your final expression right over here. Do we have it in that form? Yes, where a is a positive integer. Perfect. Move on to the next question. Question 3. If s is between -3, 0, f of x this, show that this is that. Okay, so just expand it. So we know that this over here expands to x squared plus 4x plus 4, x minus 1. And expanding that, that gives us x to the power 3 minus x squared plus 4x squared minus 4x plus 4x minus 4, which equals x to the power 3 minus x squared. Well, we don't even need a, well, we know that these common factor, so 4 minus 1, which is plus 3x squared, and these two cancel out, and minus 4. So we've shown that that equals that. Perfect. Sketch the graph of f on the axis below. Label the axial intercepts and any stationary points with their coordinates. Alright, so by looking at the factorized form, we know there's a repeated, so x equals -2 over here, and at x equals 1, so these are our axial intercepts, and we know that there's going to be a repeated root at -2. We also know that if we sub in over here 0 on these two, we get an y-axis of y equals -4. So over here. So if I was going to draw a nice graph, it would look like this. So it would pass through this and it would get reflected, something like that. So this is the general thing, but I need to really think about it because we've restricted it from -3 to 0. So if I close this down over here, enclosed here, and we're saying -3 to 0, so all of this closed down. I just want to make sure that these points are exactly right. So, how? Well, if I sub in -1 to the function, we get -1 plus 3 minus 4. So that'll be 2 minus 4, -2. So that should over here, -2, which is right, perfect. So -2. And this point over here is -3. Yep. If I sub in, perfect. And that's good. So now we've done that, I am just going to label. Well, our axial intercepts are here, -2, 0. That's actually our stationary point and our axial intercept. And this is 0, -4. So sketch the graph on here, label the axial intercept and any stationary points. And yeah, these are axial and stationary points. Those are that. -3 to 0. Perfect. Next question. Question 4. In a large population of fish, the proportion of angelfish is 1/4. Let P this, so the proportion of P be the random variable that represents the sample proportion of angelfish for samples of size n drawn from a population. Find the smallest integer value of n such that the standard deviation of P this is less than or equal to this. Okay, so we want the standard deviation of P hat to be, so standard deviation is less than or equal. So less than or equal to 1/100. Now, we know the formula for standard deviation of a proportion. It is, if I'm not mistaken, it's the square root of P hat or minus P hat all over n. So less or equal to 1/100. Now, what's our P hat in this part? Well, our P hat is 1/4. So we can say, this over here, what's 1/4 times 3/4 all over n? And we're trying to calculate n. Okay, so that should equal, so the inside, so we're saying 3/16 divided by n, which is times 1/n. So this whole thing simplifies to 3 over 16n. Yep, so 16n should be less or equal to 1 over 100. And squaring both sides, we get 3 over 16n is less or equal to 1 over 100 times 100 is 10,000. If I'm not mistaken. Yeah, 10,000. And so we have this. And, well, we can... If we multiply both... what else can we do? Is there a way? So we've done there. Squared both sides. Alright. So I can simplify these two by... So if I divide this by 2 and divide this by 2, I can become like... It will become 3 over 8n is less or equal to 1 over 5,000. And again, I can simplify it more. So this will be 4n less or equal to 1 over 25 this. And I can again simplify it. Must be less or equal 1 over 250. Is that right? Yeah. And I can again simplify it one more time to get 1 over. So what's 1250 divided by 2? So 6. 12, 50, 25. So 65. Okay, so we got 625. Perfect. And now if we cross multiply, so what's 625 multiplied by 3? So 5, 15. 3 times 2 is 6, 7. 6, 12, 18. So 1873. So we can say 1875 is less or equal to n. Now, we want n, so if we bring it to the other side, we just have to say that n must be greater or equal to 1875. And we want to find the smallest integer value of n. So our smallest integer value is n is equal to 1875. This is our smallest because it's greater than this number and it can be equal to it. So yeah, just use this. Question 5. For Jack to log on to a computer successfully, Jack must type the correct password. Unfortunately, Jack has forgotten the password. If Jack types the wrong password, Jack can make another attempt. The probability of success of any attempt is 2 over 5. Assume that the result of each attempt is independent, so we're probably dealing with binomial distribution. Of the result of any other attempt, a maximum of 3 attempts can be made. So probably n equals 3. What is the probability that Jack does not log onto the computer successfully? So wait. So we can say that, let's say x is binomially distributed, where we have 3 attempts, and we know that the success is 2 over 5. So if we want him to not succeed, we want to find the probability that x must equal 0, where he does not, the probability of him not even logging into his computer. So that will be 3 choose 0 over 2 over 5, 0, 3 over 5, power 3. That becomes 3 to the power 3 is 27 over 125. Done. That's perfect. Next question. Calculate the probability that Jack logs onto the computer successfully. Express your answer in this form, where A and B are positive. So we've just calculated it when he does not log in successfully, so it's just 1 minus the answer. So yeah, so what's 1 minus the probability of x equals 0, which is 1 minus 27 over 125, which is equal to... Alright, so if I say 70, if I add 73 plus 25, so 7, 8, 9, 5, 6, 7, 8. So, okay, it'll be 98 over 125. That's that. Next question. So let me just write that up. Calculate the probability that Jack logs into the computer successfully on the second or on the third attempt. Express your answer in this form. So he logs in on the second. So we want to find the probability first that he first fails, because he's failed for the first time. Then in the second he succeeds. So let's say S. or it means plus probability that he attempts on the third try. So he fails again, but succeeds in the third time. So that's easy. So what's the probability of, okay, so what's the probability of fail first? Well, we know the probability of failing is 3 over 5. So we can say 3 on 5 times the probability of success, which is 2 on 5. Plus the probability of failing is 3 on 5 times 3 on 5 times 2 on 5, where he succeeds. And we can say that this over here equals 6 over 25, yeah? Plus 9 over, no, actually 9. 3 times 3 is 9, 18. So 18 over 5 times 5, we get 125. So, what we're saying that 30 plus 18 all over 125, which is 48 over 125. Yeah, and you can't simplify that much further. So C and D are positive integers. Yeah, perfect. Question 6. Let tan minus 1 equal that, this, and that. So it's a factorized form. State all possible values of tan. Okay, so this over here, let it equal to 0. Let this one over here equal 0 and all of them. Okay, so tan, so we can say that tan theta minus 1 equals 0. So tan theta equals 1. That's 1. The next one is, we're saying sine theta minus root 3 cos theta must equal 0. Now, what do we know? Well, we can say that sine theta equals root 3 cos theta. If we divide both sides by cos, this becomes tan theta, and it becomes root 3. That's another tan. Perfect. Now let's do that for the last one. So we've just moved this over here. I'm gonna make them small. So for the last one. Last one is sine theta plus root 3 cos theta is equal to 0. So we can say sine theta equals negative root 3 cos theta. And if we divide both sides by cos, we get tan theta equals negative root 3. Here are your values for tan. Done. Hence, meaning that we're going to use these here to help us with this question. So it says, hence, find all possible solutions for this, where 0 to pi. Okay, well, because they're saying, okay, this over here is just if you complete, so the differences of perfect square of this is pretty much this over here, this expression over here. So let's just, yeah. So we know it's that, and we know that that equates to these. So let's find a solution for the first one, which is case 1, which is just tan theta equals 1 from 0 to pi. So if I just draw a nice graph over here, when it's tan positive, we know CA, so it's positive over here, and ST, and it's positive over here. But we want from 0 to pi, so we're going to exclude this one. So we can say that theta, the angle, is just pi on 4. Now the second one is the case where tan theta is root 3. Same thing. When is tan positive? Well, it's only positive for those values over here. So we can say that theta here, it's pi on 3. Yeah? Yeah. Just do this. That's theta, so pi on 3, root 3, 1, 2. So yeah, perfect. Works good. Third case, where now tan theta equals negative root 3. So now we want the case where it's negative. So we know C, A. And we want it from 0 to pi, so we exclude this one. We just want this one. So it will be pi minus pi on 3, which is 2 pi on 3. Done. So your solutions are, thetas are pi on 4, pi on 3, 2 pi on 3. Choose those as your answers. Perfect. Question 7, let f be this. So from 0 to infinity, f of x that. State the range of f. Okay, not too bad. So if I'm going to draw f, so it's been translated. So if I draw a nice graph, so it's been translated 1 unit to the left, so over here, and it goes like this. It's a positive. And we know we want it from 0 to infinity. So we want only this point over here, and we want to exclude that. So what's that point over here? Well, it'll be 0 to, if I summon 0, it'll be 0, 1. So your range of f is, so we can say that range of f is from 1 to infinity. Perfect. Let g be from negative infinity to c, g of x this, where c must be less than 0. Find the largest possible value of c such that the range of g is a subset of the domain of f. So we want the range of g, so range of g, to be a subset of the domain of f. Okay. So we know the domain of f here. It's from 0 to infinity. So we can say 0 to infinity. The range of g, well, let's actually draw g. Well, it's in this, so I'm just going to complete the square because it's easy. So x squared plus 4x plus 4 minus 4 plus 3, which simplifies to x plus 2 squared, 3 minus 4, which is negative 1. So that simplifies to that. So if I just draw a nice parabola here. Okay. And so it's been, negative 2 over here, negative 1. So it looks like, if I'm not mistaken, it's 1, that's 2, so here, and let's say that's 1 over here. And we know that our x-intercept's at 3, so it's around here. So if I just draw this nicely, probably passes through that point, and it probably passes through this point. Yeah. And yeah, if we solve that, so, x plus 2 squared minus 1, so let's just solve it quickly. It become plus or negative 1, x minus 2 plus or negative 1, so x is negative 3 and negative 1. So here is negative 3 and here is negative 1. Yeah, so I don't need that anymore. All right, so if we want the range of g, this function g here, to be the subset of the domain of f, so we want it to fit in this. For it to fit, we need it to make sure the range is from 0 to infinity. So if we want the range to be 0 to infinity, we are going to be deleting this part over here. This part over here. We're just going to be deleting those parts. And yeah, that's that. And so the domain is from, negative infinity to negative 3, union negative 1 to infinity. But here, we're trying to find the value of c, but we know that c is from negative infinity to c. So it can only be negative 3. So c equals negative 3. Just that. Next question. For the value of c found in part bi, this one, state the range of this. Okay, so it's a composite function, and we know that the range of g must be a subset. So it's the same as this over here, what we've just calculated. All right. So, okay, let's really understand this. So if we were going to, okay, let's say this is g first. What's the domain of g? Well, we know the domain of g is what? It's negative infinity to negative 3 using c. And what's the range? The range is from 0 to infinity. What's the domain of now f? So the domain of f is 0 to infinity. Oh, no, that's, 0 to, and what's the range of f? So the range of f, 1 to infinity. Okay, so we need to make sure that the domain of g fits in f. Fits in the, so the range of g, which we've already calculated here, must fit in the domain. So wait. The range of g, which is this one over here, must fit in this domain, which it does fit perfectly. So does that mean that your range of the whole function f g of x is just this one over here, the range of f? Because we know that the range of G must fit in the subset of domain D, and it fits perfectly. And yeah, so it only must be this one, the range of... So the range of the overall function must be the range of f. Oh, that's not too bad. So let's call it the range of f of G must be 1 to infinity. Done. Let h be this function. Okay. Alright, let me just choose. Okay, let h be this, state the range of this. So, okay, we need to first check if it actually works, like if it exists. So we need to check if the so the range of h is a subset of the domain of f. So what's the range of h? Well, the range of h, if you really draw this, it's a parabola that's translated up 3 units, and this is 3. And we know that the domain's all real, so the range here is from 3 to infinity. A subset of the domain of f, and we know the domain of f was 0 to infinity. Now, okay, the 3 to infinity is a subset of 0 to infinity, so that it does exist. So the best way that I would do this is, what is the domain of h then? The dom of h is all reals. Okay, so let's just find the function. Let's find the role of f of h of x. So f is the square root here, so x plus 1. So we're saying x squared plus 4. That's your f of h. So now drawing this, and we know the domain's all reals. So if I sub in 0, this point over here becomes 2. If I sub in 1, it comes over here and it increases. Doing the opposite still increases. So it's like a parabola pretty much. So the range is, so this is 2 here. So the range is so the range of f of h is actually from including 2 to infinity. That's that. Question 8. For events A and B, for a sample this and this, okay, so we know the intersection is P. Find probability of A in terms of P. Okay, let's first see what this does. So we know that the probability of A given B is equal to the probability of A intersection B all over the probability of B. Now here, we know that probability of A B is 1 over 5. And we know that the probability of A intersection B is P. So we can say that's P over here and all over probability of B. So your probability of B is 5p. That's useful. Let's try to find now let's do the other one. So probability of B given A is probability of A intersection B all over probability A. And we know that's 1 over 4. And that's P, and that's probability of A. So therefore A is 4p. That's that. In terms of P, yeah. That's good. At least we found B and A. Find A intersection B. Okay, this is easy. I would just straight away draw a nice diagram over here. Yeah, like that. I'll just draw a nice. Oh, well, I'll make it big actually, like this. And okay, something like that. Say this is probability of A, and this is A given, or complement, B complement, it's all to 1. So we know that the probability of A is what? Well, we know this here is P. We know that probability of A is 4p, so this will be 3p. And we know the probability of B we've calculated, which was 5p, so 5p. This would be 1 minus 5p. And we just need to calculate this over here, the x value here, which is just so probability of A, this is 1 minus 5p minus 3p, which is 1 minus 8p. Done. Given that the probability of A union B is this, less than 1 over 5, state the largest possible interval for P. Okay, so we know that the probability of A union B is just the probability of A plus the probability of B minus the probability of A intersection B. So yeah, and so we can say, what's the probability of pretty much A? We know that's 4P. Probability of B, 5P, minus the probability of A intersection, which is just P. So that'll be all together 8P. So we're saying 8P must be less or equal to 1 over 5. So we're saying that P must be less or equal to 1 over 40. Now, so we're saying P must be less than 1 over 40, but if we come over here, we need to really look at it. P is the intersection. So if P becomes 0, like for example, if it becomes 0, then they become mutually exclusive, which is absolutely not. So we want to make sure that it's not P is less or equal to 140. We don't want to go forever to infinity. So we want to make sure that P is less or equal to 1 over 40 and 0. Where, yeah, can it equal? No, we don't want to let it equal to 0 actually. Just thought about it right now. Because if it equals 0, what happens is that it becomes mutually exclusive. So be careful with that. So yeah. So for this thing to even work, we want to make sure it's not mutually exclusive. Perfect. Question 9. The graph of f is from 0 to 1. F of x, this is shown. Calculate the area between the graph of f and the x-axis. Okay, so not too bad. So if I just really simplify this by just expanding it, so it'll be root x. Or just saying, yeah, x half minus so minus x 3 on 2. Okay, so that, let's go. So the area bounded is what? It'll be from 0 to 1. So we're saying from 0 to 1 of, okay, of x half minus x 3 over 2 dx. So that integrates, okay. So let's look at the first part. If we're going to add a 1 on it, it'll be 3 over 2. And we divide it by 3 over 2, which will become 2 on 3. So we'll write that. So 2x 3 over 2 all over 3 minus, do the same for the other one. So if we have x 3 on 2, and if we add 1, it'll become 5 on 2. And to be divided by 5, it will be 2 on 5. 2x 5 on 2 all over 5 from 1 to 0. So summing those in, so summing 1 first, it'll be 2 on 3 minus 2 on 5 minus, so if I sub in 0, yeah, it just becomes 0. So we're saying that 10 minus 6 over 15 is 4 on 15. That's your area, unit squared. Perfect. For x in the interval from 0 to 1, okay, show that the gradient of the tangent to the graph of f is this. So yeah, we're just telling us to find f dash. So it's easy, so we can say that f dash of x is, we already have, wait, let's just write f dash actually first. F of x is x 1 on 2 minus x 3 on 2. So our f dash of x is 1 over 2 x, and with minus 1, it'll become negative 1 over 2. So bring that minus 3 over 2 x, and we minus 1 from it, it'll become a half. So yeah, so this all simplifies to 1 over 2 root x minus 3 root x on 2. Multiplying both sides, so cross multiplying, we'll get 2 minus 6x all over 4 root x. Taking a common factor out of 2, we get 1 minus 3x all over 4x, so 4 root x actually. So taking those out, we get f dash of x 1 minus 3x over 2 root x. Done. This is the last question. Okay. Wow, it's so tiring. The edges of the right angle triangle A, B, and C are the line segments AC and BC, which are the tangents of the graph of F and the line segment AB, which is a part of the horizontal x-axis as shown below. Let theta be the angle that AC makes with the positive direction of the horizontal axis, where theta must be between 45 and 90. Find the equation of the line through B and C. So this point here to this, we want to find the equation in the form of that. Alright, so we want this over here, where theta is 45 degrees. Okay, I know that if we know that theta is 45, we can easily find the gradient of this. Well, let me do a different kind of line. So we can find the gradient of this line over here, can't we? So if we can, oh, it's not even, let me just draw nice. Okay, we can find the gradient of this line over here. Let's call that M1. And because they are perpendicular, as we can see through this, they are perpendicular, meaning that if we know the gradient of M1, which is the line over here, we can easily find the gradient of the second one by just using, the perpendicular gradient. Yeah, let's do that. So let's find the gradient of M1. Well, to find the gradient of M1, let me just write that now. So M1 is tan of 45 degrees, which is pi on 4, which is just 1. So if that's 1, M2, the gradient of M2 is what? It's negative 1 over M1, which is just negative 1, which makes sense, absolutely. So we can say that this gradient over here is negative 1. So we know the gradient. Okay. What else can we use to our deductive skills? We need to find a point. We can find that point because it touches this point over here. We can find that point of intersection easily because we know now the gradient is negative 1. We know f dash of x is that. So we can say 1 minus 3x over 2 root x, is that right? Minus 3x, 2 root x should equal negative 1. So we can say that 1 minus 3x, negative 2 root x. Squaring both sides, we get 1 minus 3x, 4 root x. So expanding that out, that'll be 1 minus 2, 3x plus 9x squared equals 4 root x. Oh, what am I doing? No. This over here, because I squared it, it's supposed to be an x. So it'll be 4x. So it'll be 1 minus 6x plus 9x squared plus 4x. So it'll become 9x squared. So if I bring that there, it'll be minus 10x plus 1 equals 0. So what's 9x? It's factorizing it. We know that's 1, 1, negative, negative. That'll become 9x minus 1 minus 1 must equal 0. So x must equal 1. And also our x equals 1 on 9. Okay, so let's just be honest here. Which one is that point? Well, this here is 1, and this point over here is 0.5 around here, and this point is, yeah, so for 1 on 9, wait, if this point of intersection is over here, 1's over here. Is it supposed to be 1 over 9? But it doesn't make sense because the halfway through the thing is 0.5. So 1 on 9 probably is around this place over here. Just let me have a look at this line actually. Well, it looks like it's touching this point, doesn't it? Okay, but yeah, it should be that line. I think they just haven't drawn it to scale. It makes sense. It should be x equals 1. Yeah, 1 on 9th is around here. So if x is equal to 1, sub in x equals to 1 on f, what's that give you? Coming back to here, so if that's like 1, that'll be 0. Oh my god, it's the actual, x-intercept, so 1 and 0. So we can say that, by y minus 0 equals the gradient, which is negative 1, x minus 1. So y is therefore negative x plus 1. Done. That's the equation. Next question. Find the coordinates of C when theta is 45. Okay, so this point over here. So because we've already calculated M2, why don't we just calculate M1? Oh, no. Why don't we just calculate M1 and just find the intersection, equate them? Yeah, so we know the gradient of already M1 is 1. And we already have the function. So we just say, 1 minus 3x over 2 root x equals 1. 1 minus 3x equals 2 root x. Square both sides. Wait, these are the same, but just had a negative, but when we squared them, it became positive. So, doesn't that mean that x is the 1 on 9th? So, this is the point of intersection. This over here is 1 on 9. Yeah, so if this is 1 on 9, we already know where it points of intersection. So, what's f of 1 on 9? So, what's f of 1 on 9? Let's check that. So, if I have something 1 on 9, so what's the square root of 1 over 9? 1 minus 1 on 9. So, we're saying 1 on 3. 8 on 9. 8 over 8, 9, 18, 27. 8 over 27. So, 8 over 27. Okay. That's good. So, we know that. So, we can, now we know the gradient of M1 is negative 1. Yeah, so now it's just, we have everything. So we can say y minus 8 over 27 equals 1x minus 1 on 9. So that will become y equals x minus 1 on 9 plus 8 over 27. So y equals x. Okay. If we say, so we're saying 1 on 9 plus 8 on 27. Plus 8. 8 minus 3 is 5 over 27. So plus 5 over 27. Done. Is that right? Yeah. Plus 5 over 27. It crosses this over here. So should be 5 over 27 should be in the positive. So now we have that. So we just equate them. So what's x plus 5 over 27 equals negative x plus 1. That'll be 2x. 1 minus 5 over 27. So it will equal 2x. Alright, so 15 plus 7, 22. So it'll be 22 over 27. So it will just become x is equal to 11 over 27. Yeah, so now we know x, and it's just saying what's f of 11 over 27. Or not even f. One of these equations, which the easiest one is this one. So what's negative 11 over 27 plus 1 equals y. 19 plus 7. So we're saying 20 plus 6. So 26. Is that right? So if I... Oh, no, actually, wait. 16. Yeah. So 16 over 27. So y 16, 27. Yes, that's good. So that'll be 16 over 27. Your coordinate of C is 11 over 27, 16 over 27. Done. Hope that's right. I have to check my answers. I hope you guys enjoyed the video and learned something. Please, if you guys see anything that's wrong, please make sure comment down below. I'll try to fix it. And yeah, thank you guys for watching, and I hope you learned something through this video. Please make sure to like it and subscribe and share it with your friends. Have a good day, guys. Take care. Bye bye.